Guys, welcome yet again. Guys, let's do this problem and I read it first. Find the transfer function of SFG below, that is signal flow graph. So guys, we start to do this question. The first thing guys we are going to look for is the forward path gains. And for the forward path gain to find is that guys we are going to look for all the forward path. So guys, let me now go ahead and show you the forward path. The first path guys we are going to have is this. From the source node, you move through through 1, then you go to G2, you go to G4, you go to G3 until you go to the sink node. Guys, what you make sure is that you do not traverse any node twice. And so therefore guys, we have that one path. And as you can see, I have written it down right here. Guys, I'm talking about this path. You go G2, G4, G6, and that is the path even as I have demonstrated right here. That is G2, G4, G6, and then up to the sink node. The other path, guys, we can take is this path. That is 1, G3, G5, G7, and then 1 and up to sink node. So guys, that is also another path. As you can see, it is right here. It goes like this, like this. That is G3, G5, G1. You don't have to write the ones. Then we have the path 3. For the path 3, guys, we use this route. We go 1, G2. This is G. Let me look at it very well. It's actually G1, G7. And that is given by this path. G2, G1, G7. Guys, we also have this other path. That is path 4, which moves now through here. That is 1, G3, G8, G6. And that's what we have. G3, G8, G6. And finally, not finally, but path 5. Guys, we can move like this. We move 1. That is now G3. Then we can move G5 like that. Sorry, not G5 but G8. That is G3, G8, H1. Guys, when we come here, we might have some reservation. Maybe somebody can ask, how come? And this looks like back feedback. Guys, as long as you are not transversing any node twice, that is still a forward path. Problem is where you transverse a node twice. So we can go 1, G3, G8, minus H1. As you can see, we have not touched any node twice. Then you go to G1, and then you go to G7, and then you go to the sink node. And that is what we have here. Guys, another path here we have is now on this other side. You go to G2, then you go to G1, G2, G1, minus H2, G8, and G6, and then you exit to, that is to the output CS, and that's what is represented here. So those are our path. The second thing, guys, we come is to the loop gains. For the loop gains, we have 3 loop gains here. One is G4, H1, negative H1, and another one here, G5, negative H2. And guys, we also have another one here. As you can see, you can move this way. You can actually start here. You move H2, G8, H1, G1, like that. Guys, as you can see, you have started here, H2, G8, negative H1, G1, and we are back. And so that's what is demonstrated here, guys. So we have H minus H2, G8, H1, G1. After that, guys, we now come to non-touching loop gains. Guys, you have not yet talked about non-touching loop gains for our last questions, but here we have non-touching loop gains. So let's look. Guys, you can see this, we have only 3 loops. If you look at this loop here and this loop, they are not touching anywhere, meaning that any signal moving onto this loop and another one moving onto this loop, they will not come into contact at any time. And so we call those two non-touching loop gains. Then from there, and this is what we now look for, is their product. We write them as 2, taken 2 at a time. Non-touching loop gains taken 2 at a time. That's what we say. Then when we come to the path determinant, guys, we have here path. We have the delta, which is 1 minus all the loops gain. That is summation of the loops gain plus non-touching loop gains taken 2 at a time. That is the product of the loop of the non-touching loop gains. And we have these two. That is for L1 and L2. You check L1, guys. This is L1 and L2. You multiply that. Those two are non-touching loop gains. We come now to the delta 1. Delta 1 will be 1 minus. That will be the delta when the first path is removed. So guys, if we come and remove the first path, and the first path we had was moving through this. We moved through this route, that route, and we went until this point. So guys, if we rub this, you find that this one will not be touched, and so this one will remain. And so we shall have 1 minus G5 minus G5H2. The same case, and therefore it will be 1 plus G5H2, that is delta 1. For delta 2, we now come to this path. This was our P2. So guys, if we lab also this path, we find we shall still remain with this loop. And so our delta will be 1 minus that loop. And that is 1 minus that loop. And so it will be 1 plus G4H1. So delta 1 and delta 2 have values of that. Coming to delta 3, we go to loop number 3. For loop number 3, guys, this path was now moving, not loop number 3, but for path number 3. For path number 3, if we check here, as you can see, guys, it's moving like that. So in our whatever, the graph, it's supposed to move like this. So as we move like this, guys, you can see we are touching that loop. We are also touching this other loop we had formed. And when now we move down, guys, find we are also touching that loop. And then we go out. Meaning that, guys, if we were to remove that loop, this loop, guys, we will not have any loop remaining. And so we shall have 1 minus 0. As it is written here. Guys, if you go to the path 4, the path number 4, it will still be like that. You go back and check path number 4 and see whether it touches these two loops. If it touches these two loops, then it will be 1 minus 0. Because when you remove that path, these two loops will not be there. Go to delta 5, that is path 5, the same, and path 6 will still be the same. Guys, now we come to what we call the Mason gain formula. For the Mason gain formula, we have it right here. And now just, guys, we just come and fix our figures. Of course, this is now, because we have path 2 up to path number 6. This is the formula we are going to use. And so, guys, from there, we just come and fix our P1 and delta 1, P2, delta 2, P3, delta 3, like that up to P6 delta 6 all over the delta. So once guys you fix all those figures, because already we have identified them, this is what guys we are going to find. As you can see, it's very long, very long, very long. This is up to that point. This is what we call our transfer function. And so guys, thank you for listening to me. Bye bye.